If you're interested in VLSI and integrated circuit design, then you might be interested in a class this coming spring semester called Linear Integrated Circuits. This is the one class at WVU that focuses on these topics and will prepare you for doing advanced electronics design and integrated circuit design. This course is going to focus on CMOS technology. We'll start from first principles to get an understanding of how MOSFETs work. Then we'll build upon that knowledge to be able to design increasingly complex circuits, building up until you are able to design your own operational amplifier to meet required specifications. You'll learn that IC design is a whole lot more than just creating schematic. There's this whole other portion of the design related to the physical aspects, including how you size, orient, place, and interconnect the devices at design time. This is a true flipped classroom and project-based course. I'll talk more about the inner workings of this class momentarily, but I just want to talk about who can take this class first. This class has been and will continue to be a core class in the master's and PhD programs. We've actually had a few undergrads take this class in the past, and they've done quite well. And this semester, we're officially opening it up to undergrads, and they can take it now officially. So we'll be running both the graduate and undergraduate sections simultaneously. We'll all meet together, we'll all work together. If you're an undergraduate student, you should sign up for EE 493B, and if you're a graduate student, you should sign up for EE 551. You'll have a few extra requirements because it's a graduate level course, but nothing too terribly difficult. So who can actually take this class? Well, basically anyone who has at least some background in circuit analysis. There may be some official prereqs for the class, just ignore them. Here's what you really need to know to be able to take this class. First, if you're an undergraduate student and you've taken EE 355 analog electronics, you're all set. If you're a graduate student, then all you need is graduate student standing, but I kind of recommend that you would have some background in circuit analysis. Otherwise, we're going to basically start from first principles and build up from there. So really anybody who is motivated can take this class and do well in it. If you do run into any issues with prereqs causing problems with registration, just let me know and I will work with you to get that taken care of. If you've taken a class from me in the past, this one will feel a good bit different. We're really going to focus on design and projects in this class. So to that end, this class will be taught in a true flipped classroom style. We're going to meet for about 1 hour each Monday night, starting about 6 p.m. We'll use that time to solve problems together and to discuss upcoming projects. This is going to be a very interactive time, and we'll focus on practical aspects. Even though it's scheduled for a 3-hour time slot, we're really going to try to focus and get it down to 1 hour. That's because you'll have a number of asynchronous videos to watch during the week that cover the theory, typically about an hour or two's worth of videos. The rest of the time you'll spend working on projects. We typically have about 8 projects, plus or minus 1, plus a final design project where you have to design an operational amplifier to meet given specifications. Generally, people work with a partner on these projects, and the projects for the first half of the semester tend to focus on data analysis, making sure that these models that we're developing for CMOS devices really work and do what we say they're going to do. And then in the second half of the semester, we're going to really focus on design aspects using SPICE. So the first half will leverage MATLAB. If you're not a huge MATLAB expert, don't worry, I'll coach you through what you need to know. So don't worry there. And in the second half, we're going to focus on SPICE and teach you much more in-depth usage of SPICE and other CAD tools for integrated circuit design. Overall, I really love to teach this class. It provides the fundamentals of IC design and VLSI systems, which are the backbone of all of our computing technologies today. Most students tell me that they really enjoy the project-based curriculum and that they learn a ton in the process. If you have any questions, please reach out to me. I'd love to get you any information you need to have to determine if this class is right for you. If you're unsure, please feel free to stop by at class on Monday at 6 p.m. and to check it out and to learn a little bit more. Hope to see many of you in class this semester.